Welcome back, focused learners. Picture this. You sit down at your desk, the examiner says, "You may begin," and you are officially looking at 90 minutes to glory. This is the championship final of your academic year. But if you've ever found yourself staring blankly at a complex geometry problem on a Cambridge 0580 mathematics exam, wondering where to even begin, you are in the exact right place. Today, we are opening up a highly strategic playbook specifically designed for mastering area and volume concepts. Now, I see two types of students all the time when I grade these papers. First, there's Alex. Alex overloads on raw mathematics facts, memorizes 100 formulas, but has absolutely no analysis or strategy when a weirdly shaped object pops up. Then there's Sam. Sam rushes, completely misses the specific command word requirements in the question, and throws away easy marks despite knowing the math. We've all been Alex or Sam at some point, right? You end up with a paper covered in red pen marks? Well, today, we're going to transform how you look at shapes. We are shifting away from that stressful rote memorization and learning to truly see the logic behind the mathematics. Whether you are tackling the 0580 or looking ahead to the 0606, 4024, 4037, or 4040 syllabuses, this is your ultimate game plan for exam victory. By the end of this explainer, those intimidating 3D structures won't look so scary anymore.
Here's our logical game plan for today's session. First, mastering 2D plane shapes. Second, unfolding surface area tactics. Third, the exact form strategy. And finally, conquering prism volumes. Let's get right into it.
Section 1. Mastering 2D plane shapes. We need to secure our base plays before we can tackle the complex stuff.
Okay, let's look at how top-tier students structure their thinking. Instead of just memorizing a random list of formulas like Alex does, I want you to start visualizing these shapes dynamically. This is where we introduce our analytical framework. Let's look at the parallelogram on the left. If you just look at the raw shape, it might seem tricky, but imagine snipping off that triangular piece on one angled side, picking it up, and sliding it perfectly over to fill the gap on the other side. What do you actually get? A perfect, straightforward rectangle. That is exactly why the area of a parallelogram is literally just its base length multiplied by its perpendicular height. It's a rectangle in disguise. Now, what about a trapezium? Sam usually rushes this and uses the wrong formula. But if you take your pen and draw a single diagonal line straight through the middle of that trapezium, you've just split it into two simple triangles. The first triangle at the bottom has an area of 1/2 of its base, which we'll call A, times the height. The second triangle, upside down on top, has an area of 1/2 of its base, B, times that exact same height. If you add those two areas together and factor out the common elements, the half and the height, you mathematically arrive at the classic trapezium formula, 1/2 times the height times the sum of the parallel sides, A plus B. Understanding exactly where the formula comes from makes it almost impossible to forget under exam pressure. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's put this into practice with a classic multi-step exam scenario, the dreaded shaded area question. This brilliantly illustrates how complex exam problems are literally just combinations of the basic shapes we just talked about. Let's say you have a large rectangle, but there's a trapezium cut out right from the middle of it, and you need to find the remaining shaded area. We break this down into 3 simple, bulletproof steps to guarantee top marks. Step 1. Point your focus to the largest shape. Calculate the total area of the outside rectangle first. If our base is 12 and our height is 8, we multiply those to get exactly 96 square centimeters. That's your first piece of evidence. Step 2. Focus entirely on the inner cutout shape, our trapezium. Using that logical formula we just built, if the height is 5 and the two parallel sides are 3 and 5, we calculate 1/2 times 5 times the sum of 3 and 5. 3 plus 5 is 8, half of 8 is 4, and 4 times 5 gives us an area of exactly 20 square centimeters. Finally, step 3. We link it all together. Just subtract the cutout shape from the total area. 96 minus 20 leaves us with a final shaded area of 76 square centimeters. Deconstruct, calculate, and subtract. It turns a seemingly impossible problem into basic arithmetic.
Section 2. Unfolding surface area tactics. Upgrading from flat 2D areas to total 3D surface spaces. Let's move to our defensive formations. We are upgrading to 3D now, and this is where the real transformation happens. This is where we turn those red pen marks into green check marks. So, the absolute crucial point here is that when the exam paper throws a 3D shape at you, like a cylinder, your very first instinct, your very first move, must be to mentally flatten it out. We call this the net of a solid.
It is a 2D visualization of an unfolded 3D shape. Think about it like peeling the paper label off a soup can. What does a cylinder actually consist of when you break it down? It's just two identical circular pieces, one for the top lid, one for the bottom base, and one large rectangular piece that wraps all the way around the side. Once you see the cylinder as just one rectangle and two circles laid flat on a table, calculating the total surface area goes from being a massive headache to being incredibly straightforward. You're no longer calculating the area of a 3D object. You're just finding the area of three flat 2D shapes and adding them up.
Stop scrolling! Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Now, let's apply this exact same unfolding logic to a cuboid and treat this like a quick data scan challenge. Instead of blindly trying to plug numbers into that long, confusing formula, 2WL plus 2LH plus 2WH, I want you to visualize the individual faces. A cuboid is simply 3 pairs of matching rectangles. Let's look at a practical example. Say we have a cuboid with dimensions 10 by 5 by 7. You have 60 seconds on the exam clock. How do we break it down? First, pair up the top and the bottom. That's 2 identical rectangles, each measuring 7 by 10. 2 times 70 gives us 140. Next, pair up the front and the back faces. That's 2 rectangles, each 5 by 10. 2 times 50 gives us 100. Finally, pair up the 2 smaller end sides. That's 2 rectangles, each measuring 5 by 7. 2 times 35 equals 70. Add those logical chunks together, 140 plus 100 plus 70, and you get your total surface area of 310. It is beautifully systematic, highly organized, and it literally eliminates the chance of getting tangled up in a messy algebra error.
Section 3. The exact form strategy. A crucial mid-game pivot that examiners love to test.
All right, it's time for a quick Find the Flaw challenge. Let's talk about a specific high-level exam strategy where Sam always, and I mean always, loses marks. Take a look at this quote. It explicitly states that leaving your answer in a format like 60 pi is called giving the answer in terms of pi or in exact form. When you are dealing with circular formulas, like the surface area of that cylinder we just mentally unfolded, you will inevitably be dealing with the number pi. The flaw that so many students make is that the second they see pi and they're working out, they immediately reach for their calculator, smash the pi button, and round the long, messy decimal down to 3 significant figures. But if the command word in the question specifically asks for exact form, touching that calculator is going to cost you the final accuracy mark.
Notice how elegant, compact, and frankly mathematical this expression is. 60 pi. This right here is exactly what Cambridge examiners are hunting for when a question specifies exact form. Let's play this out. Let's say you calculated the total surface area of a solid cylinder with a radius of 3 and a height of 7. The core formula, 2 pi r times the sum of r plus h, gives us 2 pi times 3 multiplied by 10. If you just multiply the whole numbers, 2 times 3 times 10, that mathematically simplifies perfectly to 60 pi. Now, while writing down the rounded decimal of 188.5 might be required if they ask you for 3 significant figures, 60 pi is mathematically pure. It has not lost a single fraction of a decimal point of precision to rounding. This is a massive distinction. Always, always decode the command words in your exam questions carefully so you know exactly when they want this beautiful exact form.
Section 4. Conquering prism volumes. Executing the ultimate play for non-standard 3D shapes. First things first, we absolutely must define exactly what a prism is. A prism is not just a triangular piece of glass that makes rainbows. In mathematics, a prism is any 3-dimensional object that has a constant cross-sectional area. Think of it like a freshly baked, perfectly rectangular loaf of bread. If you take a knife and slice it from the front all the way to the back, every single slice you cut is the exact same size and the exact same shape. It doesn't get wider in the middle or taper off at the end. Because of this specific geometric property, calculating the volume is remarkably simple. You don't need a complex 3D formula. You just find the flat 2D area of that very front slice, which we call the cross-section, and then you simply multiply that area by the total length of the object stretching back into space.
Which leads us perfectly into a classic, high-mark exam-style challenge. We know how to handle a regular cuboid, and we've demystified the cylinder. But how on earth do you calculate the volume of an L-shaped prism? You look at it and your brain freezes because there is absolutely no standard mathematical formula for an L shape. Alex would sit there trying to remember a formula that doesn't exist. This is the ultimate test of the geometric toolkit we have been building today. How do we apply our game plan to an impossible shape?
The secret is to go right back to what we learned in Section 1, deconstruction.
We look at that intimidating, complex, L-shaped cross-section, and we refuse to be overwhelmed. We simply draw a straight line and chop it into two completely manageable basic rectangles. Let's walk through this strategy step by step. Let's do a speed run. Step 1. Split the cross-section. Let's say we draw a vertical line. We've now created a tall rectangle A on the left, which has dimensions of 5 by 2, giving it an area of 10. We are then left with a smaller rectangle B kicking out to the right, which is 5 by 1, giving it a simple area of 5. Step 2. We sum the total cross-sectional area. 10 plus 5 gives us a constant cross-section of 15 square centimeters for the entire L-shaped face. Now for the final, satisfying step. We know our fundamental, unbreakable prism rule. Volume equals the cross-sectional area multiplied by the total length. If the total length of this 3D L shape stretching back into the page is 5 centimeters, we simply take our cross-section area of 15 and multiply it by that length of 5. 15 times 5 is exactly 75 cubic centimeters. Look at what we just did. We took a complicated, non-standard 3D shape, we flattened it out, we chopped it into pieces, we solved the basic arithmetic, and then we stretched it right back out into an elegant full-mark answer.
And that, my friends, brings us to the core takeaway, the ultimate system from today's explainer. Achieving top marks in geometry isn't about memorizing 100 different formulas for 100 different obscure shapes. It is about developing an absolute deconstruction mindset. It's about looking past the complexity. Every single complex shape that Cambridge can throw at you is just a combination of simpler, friendly shapes waiting to be revealed. If you remember our 3 rules, decode the command words, deconstruct the shapes logically, and manage your time by stepping through the arithmetic systematically, you will secure those marks. So I leave you with this final provocative thought. If complex 3D volumes are really just basic 2D shapes multiplied by their length, what other seemingly impossible shapes are you going to flawlessly deconstruct on your next exam? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.